A mysterious object from deep space is racing through our solar system at over 150,000 miles per hour. Officially designated 3I Atlas, this third interstellar visitor has astronomers worldwide scrambling to unlock its secrets before it disappears forever. Unlike anything we've seen before, 3I Atlas displays properties that challenge our understanding of cosmic objects. Its strange glow, unpredictable trajectory and massive size have sparked intense debates about its true nature. Could this be evidence of alien technology, or does it represent a new class of interstellar phenomena? The clock is ticking as scientists race to solve this cosmic mystery. A rare visitor from deep space. Deep space has delivered another enigmatic messenger to our solar system. 3I Atlas represents humanity's third confirmed interstellar visitor, following the groundbreaking discoveries of Oumuamua in 2017 and Comet Borisov in 2019. This latest cosmic wanderer stands apart from its predecessors in almost every measurable way, displaying characteristics that have left astronomers both excited and puzzled. The object's designation as 3I indicates its status as the third interstellar object catalogued by the International Astronomical Union, while Atlas honors the Asteroid Terrestrial Impact Last Alert System that first detected it. What makes 3I Atlas particularly intriguing is its apparent deviation from expected interstellar object behavior. Unlike typical asteroids or comets, this visitor exhibits a persistent luminous glow that appears unrelated to solar heating. Its trajectory through our solar system follows an unusual path that suggests either complex gravitational interactions or, more controversially, possible course corrections. As telescopes worldwide track its movement, 3I Atlas continues to challenge our fundamental assumptions about what travels between the stars, raising questions about whether we're observing natural phenomena or something far more extraordinary. The breaking discovery. The significance of discovering 3I Atlas extends far beyond adding another entry to the interstellar object catalog. Dr. Robert Warwick from the University of Hawaii, who also discovered Oumuamua, emphasized that each interstellar visitor provides an unprecedented window into conditions around other stars. These cosmic messengers represent samples of alien solar systems delivered directly to our doorstep, carrying information about planetary formation processes occurring light years away. The rarity of such objects makes every detection precious. Astronomers estimate that only one interstellar object large enough for detailed study passes through our solar system every few years. 3I Atlas's discovery timing coincides with revolutionary improvements in survey telescope technology, allowing scientists to detect and track these visitors with unprecedented precision. Dr. Matthew Holman from the Harvard-Smithsonian Center for Astrophysics noted that the object's properties differ significantly from both previous interstellar visitors, suggesting we're only beginning to understand the diversity of materials traveling through interstellar space. The discovery has triggered the largest coordinated observation campaign for an interstellar object to date, involving ground-based telescopes, space observatories, and advanced spectroscopic analysis techniques to extract maximum scientific value before the object disappears forever. The discovery story. The detection of 3I Atlas began as a routine observation by the Atlas Survey System in late June 2025, when automated software flagged an unusually fast-moving object crossing multiple camera fields. Dr. Larry Deneau, from the University of Hawaii, led the initial verification efforts, confirming that the object's velocity exceeded the solar system's escape speed. Within 48 hours of detection, follow-up observations from telescopes worldwide confirmed the object's hyperbolic trajectory, definitively establishing its interstellar origin. The Minor Planets Center coordinated global tracking efforts as astronomers calculated that 3I Atlas had already been traveling through our solar system for several months before detection. Dr. Gareth Williams, director of the Minor Planets Center, noted that the object's brightness variations suggested either active outgassing or an unusually reflective surface that changes orientation as it tumbles through space. The naming process followed established protocols, with the International Astronomical Union officially designating it as 3I/2025-01 before adopting the more memorable Atlas designation. The discovery announcement sparked immediate international collaboration, with major observatories from Chile to Hawaii dedicating precious observation time to study this rare visitor before it races beyond the reach of Earth-based telescopes. a stranger in our midst. So, here's the thing about 3I/Atlas. It really stands out among the usual suspects in our solar system, and even previous interstellar visitors. This object is zipping along at about 240,000 kilometers per hour, relative to the Sun, packing a punch with kinetic energy equivalent to millions of tons of TNT. Now, Dr. Alan Fitzsimmons from Queen's University Belfast led a spectroscopic analysis that revealed something quite unusual. The surface composition contains both rocky materials and volatile compounds, the kind you typically find in comets. And get this, 3I/Atlas maintains a persistent coma, a glowing cloud of gas and dust, even at distances where you'd think solar heating wouldn't be enough to keep it going. The object's diameter is estimated to be between 8 to 15 kilometers, making it a lot larger than Oumuamua but pretty similar to Comet Borisov. Photometric measurements tell us that 3I/Atlas rotates every 6.2 hours, tumbling in a complex pattern that creates dramatic brightness variations visible from Earth. Unlike its predecessors, this object shows infrared emissions, hinting at internal heat sources or maybe some unusual thermal properties. Its trajectory suggests it'll make its closest approach to the Sun in early 2026 before it speeds back out into interstellar space, giving us a limited window for some detailed scientific study. The predecessors. Alright, let's take a look at the predecessors, shall we? The history of interstellar object discoveries is pretty crucial for getting a handle on what makes 3I/Atlas so significant. Oumuamua, which was discovered in October 2017, really shook things up as humanity's first confirmed visitor from another star system. Dr. Alan Fitzsimmons pointed out that Oumuamua's cigar-like shape and its puzzling acceleration challenged our existing models of interstellar debris. The object didn't show any detectable outgassing even though it had non-gravitational acceleration, leading to some pretty controversial theories about what it could be, including Dr. Avi Loeb's idea that it might be alien technology. Then there's Comet Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov. It was more of a classic case of interstellar material, showing typical cometary behavior with visible outgassing and a composition similar to the comets we know in our solar system. Dr. Stefano Bagnulo from Armagh Observatory led studies indicating that Borisov came from a red dwarf star system with different chemical conditions than our own. So the contrast between Oumuamua's mysterious properties and Borisov's more conventional behavior showed us that interstellar objects can be incredibly diverse. Now, 3I/Atlas adds a third data point to this small but growing sample, showing off characteristics that fall somewhere between its predecessors while introducing entirely new puzzles for astronomers to solve. The cosmic journey. Now, let's talk about the cosmic journey of 3I/Atlas. Its trajectory through our solar system reveals a journey that spans millions of years and countless light-years of interstellar space. Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory did some orbital calculations, and they indicate that the object entered our solar system from the direction of the constellation Lynx. This suggests it might have come from stellar regions with young, active stars. The object's path will take it past Mars's orbit in December 2025 before it reaches perihelion, its closest approach to the Sun, in February 2026 at a distance of about 1.1 astronomical units. Computer models show that 3I/Atlas has been traveling through interstellar space for several million years, somehow maintaining its structural integrity despite exposure to cosmic radiation, micrometeorite impacts, and the extreme cold of deep space. Dr. Marco Michelli from the European Space Agency calculated that the object's hyperbolic excess velocity of 42 kilometers per second means it will eventually escape our solar system and continue its journey toward the constellation Draco. This trajectory analysis gives us some clues about the object's possible origin, suggesting it might have been ejected from a young stellar system where planetary formation processes are still actively reshaping the local environment. A scientific gold mine. So, 3I/Atlas represents, honestly, an unprecedented opportunity to study pristine material from another star system, and all without the expense and complexity of, interstellar missions. Dr. Michelle Bannister from the University of Canterbury is leading international efforts to maximize the scientific return from this rare visitor by coordinating observations across multiple wavelengths and telescope platforms. The object's extended visibility period, That's about 18 months from discovery to final detection limits, gives astronomers their longest observation window for any interstellar object to date. Spectroscopic analysis has already revealed the presence of water vapor, carbon monoxide, and complex organic compounds in the object's coma, offering direct samples of materials that formed around distant stars. Dr. Bin Yang from the European Southern Observatory noted that studying 3I/Atlas's composition gives us insights into planet formation processes happening in stellar environments with different metallicities and radiation fields than our own solar system. The object's active outgassing lets researchers probe its internal structure and composition, as solar heating liberates buried materials that have stayed frozen for millions of years. This natural excavation process really provides access to unaltered samples of the primordial materials from which alien worlds might form. Unanswered questions. Despite months of intensive observation, 3I Atlas continues to pose fundamental questions that really challenge our understanding of interstellar objects. Dr. Olivier Hainaut from the European Southern Observatory identified several anomalous properties that resist conventional explanation, including the object's persistent brightness at distances where solar heating should be minimal. Size estimates actually vary dramatically depending on measurement techniques, with radar observations suggesting a compact, dense object, while optical measurements indicate a larger, more diffuse structure. The object's spectral characteristics show unexpected features that don't match known asteroid or comet compositions, suggesting either exotic materials or, unusual surface processes. Dr. Robert Werik noted that 3I Atlas exhibits non-gravitational acceleration similar to Oumuamua, but the magnitude and direction of these forces don't correlate with observed outgassing patterns. Most puzzling is the object's variable infrared emission, which appears to cycle with a period different from its rotation, suggesting either internal heat sources or complex thermal properties, unlike any known solar system body. These mysteries really highlight how little we understand about the conditions and processes that shape materials in other stellar environments. The alien question. The possibility that 3I Atlas represents artificial technology has emerged as a controversial but persistent theme in scientific discussions. Dr. Avi Loeb from Harvard University, who famously proposed that Oumuamua might be an alien light sail, has noted several properties of 3I Atlas that could potentially indicate artificial origins. The object's controlled appearing trajectory and persistent energy emissions might suggest propulsion systems or power sources beyond natural explanations. However, Dr. Michelle Bannister and other mainstream astronomers argue that all observed properties can be explained through natural processes, citing the object's clear outgassing signature and spectral composition consistent with icy planetesimals. The artificial hypothesis faces significant challenges, including the object's fragile structure, which would likely disintegrate under artificial acceleration, and its chemical composition matching natural materials found in protoplanetary disks. Dr. Paul Chodas from NASA JPL emphasized that extraordinary claims require extraordinary evidence, noting that current observations, while intriguing, fall within the range of exotic but natural phenomena. The debate reflects broader questions about how scientists should approach anomalous observations and what standards of evidence apply when evaluating potential signs of extraterrestrial technology. Observing the visitor. Global telescope networks have mobilized in an unprecedented coordinated campaign to study 3I Atlas before it disappears beyond detection limits. Dr. Kelly Fast from NASA headquarters coordinates observations from ground-based facilities, including the Very Large Telescope, Keck Observatory, and ALMA radio array, while space-based assets like Hubble and James Webb provide crucial high-resolution data. The James Webb Space Telescope has proven particularly valuable, using its infrared capabilities to study the object's thermal emissions and composition with unprecedented precision. Dr. Heidi Hamel, Webb's interdisciplinary scientist, reported detecting complex hydrocarbon signatures and isotopic ratios that provide insights into the stellar environment where 3I Atlas formed. Hubble's observations have revealed the object's detailed coma structure, showing jet-like features that suggest localized outgassing from specific surface regions. Amateur astronomers worldwide have contributed valuable photometric data, tracking brightness variations that help determine the object's rotation period and shape characteristics. This global collaboration really demonstrates how modern astronomy leverages both professional facilities and citizen science to maximize scientific return from rare astronomical events, creating the most comprehensive dataset ever assembled for an interstellar visitor. 3. iAtlas has opened a new chapter in our exploration of interstellar space, providing unprecedented insights into the materials and processes that shape alien solar systems. While questions about its true nature remain, this cosmic visitor has demonstrated that our galaxy is filled with wandering messengers carrying secrets from distant worlds. Whether 3i-Atlas represents natural phenomena or something more extraordinary, it has fundamentally changed our perspective on what travels between the stars. Which aspect of this interstellar mystery fascinates you most? Share your thoughts below. If you enjoyed this cosmic adventure, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries.